Hello and thank you for watching this presentation. Last year, we as RFIDdirect presented the development of a patented microchip that can be used in timber to uniquely identify individual products such as fire doors and fire door frames. The patented design is offsetting all negative elements such as moisture, physical stress as caused by natural swelling and shrinkage useful in timber, as well as the chemical extractions over time. If you want to know more about this development, please contact me and I will provide you with a published article describing this development. This year, we will use the presentation to focus on using this microchip as a part of the product traceability within a production line. This with the aim to introduce lean and efficiency, reduce waste, and uniquely identify each individual product. The term smart and Industry 4 are often used in a popular way, but the underlying process makes perfectly sense for any manufacturing company. In almost all manufacturing plants, the sales order creates the production planning. The outcome is then given to the production to start the production cycle. Commonly, these production cycles and production planning is produced in ERP software systems. As in almost all industrial timber manufacturers, these sets of production information is printed on paper and given to the production foreman to start the production. In the production process, collected data is then handwritten on the documents to give back to the office for manual input in the system. With a unique identification of your products electronically using the RFID chip, each individual item can be identified electronically and automatically. Capturing the data produces the opportunity to trace reversibly all individual products, all individual parts used, the suppliers of these parts, and all the qualification standards, including the machine settings and the processes relating to this product produced. Recall of a product produced in the same batch can suddenly be done very efficiently. If your products are critical for health and safety, the information reinstallation, annual inspection, certification and maintenance is of importance to you and to your liability. The embedded identification in the product will help to identify the right product. In general, the timber industry has not adopted the automatic data capture technology in big numbers yet. Though the new generation production machines, as used in the bigger companies, are all CNC controlled and offer machine data output, which is a begin. But connecting these machine data to actual and real-time process data would be a next step. However, in most timber industries, data is collected pen and paper. As a result, the production management does not have real-time information about the process. Staffing and corrective actions are often undertaken in responsive style instead of a planned manner. Time and motion studies and continuously quality improvement programs are very useful tools in the study of manufacturing systems, though the results obtained from conventional analysis are lacking in detailed description and the system current states. As mentioned just before, most manufacturing companies today, production itself is guided with paperwork instructions, job cards, BOM lists and much more. Sometimes even whiteboards are used, placed in the central points in the production environment to catch some information or provide information. All in all, catching that process data is still in paper, pen methodology. Written down on the end of the shift or even at the end of the day, in a coffee break or whenever there is a spare moment. Information collected is physically walked through to the office for retyping into a computer system, time-consuming and prone from human errors. All this data collected is related to job card or production order, not to monitoring the process of manufacturing. It can happen that ad hoc changes in the production flow due to an urgent job are a standard without realizing the further consequences of used materials, process time, customer waiting time and customer satisfaction. It doesn't have often an accurate registration of used components other than the components used impact on the inventory management, with hardly any registration of scrap materials or lost process time, machine setup times, machine idle times. All in all, providing nothing more as an indication of the process performance, it doesn't provide you with an actual and real-time status nor performance of your production process. At our project at UK Fire Doors, we asked the management what they saw as their main performance indicators and used these as a base for our data capture system. For the actual design, we used a framework, building the metrics for our manufacturing process. We used a reference model PQAM, Production and Quality Activity Model. This model framework is made of 4 components. It's hierarchical, it's reference information structure. It's a quantitative and qualitative EDEF analysis. It uses manufacturing database and evaluation methods for exploiting the data and assisting decision making on continuously improvement issues. Adapting the EDEF modeling, we turned it into a quantitative and a qualitative data model that represents and stores all information needed for subsequent analysis of times, performance rates, material flows, unit cost, inventory availability rates, all that the relevant information to manage your process. The final step then was creating the user interface orientated towards being used by manufacturing operators and not just the management. It is for all to understand what a production process does. This film shows the early tests we conducted at UK Performance Doors in Mold, North Wales. The ID tag is placed on the core in an earlier phase of the production, identifying each product uniquely. At the lipping process, the unique ID is recorded, the job car relation checked. Process times and critical values are measured, all contributing to the key performance indicators for this process. On the end of the lipping process, the unique ID is recorded, meaning that the production of this individual door has gone through this location of the production at A date, B time and C overall time, and is ready for the next phase in its production. The lipping machine just shown in the film can be represented with the graphics as shown below. Each process starts with the machine operator or operators identifying themselves on the system as the ones operating the machine on this shift or this day. The electronic system planning informs the operator, read the job card and production process instructions as scheduled via the interactive screen near the machine. The parts are delivered to the machine and identified via the RFID tag at the start of the process, say the goods in area if you like. Automatically scanning the materials at item level into the system as available, checking with the job card, the BOM list, if the correct materials and quantities and queue approvals are delivered to the machine. This logs a date and timestamp on the process location, holding before production. Materials ready, production ready. The machine operator selects the operation mode, setup, production pre-process or actually process time for his interactive screen, or alternatively we take the inputs from the CNC machine data bus output. The produced products are scanned on the output of the machine, automatically counted, listed and stacked, ready to move to the next phase of production. The unique identification of each individual product via its RFID tag is allocated to the production batch. Additional parts are scanned, identified and added to the production batch for reverse traceability and accountability, but also for inventory management accountability. Scrappages, additional handling and all materials used are fed into the system via scanning the individual items and using the interactive screen. To improve your overall production performance, the most critical challenge will be cost reduction. This in combination with effective capacity planning to fulfill your orders and on time. This requires real-time information about your production process, continuously developing improvements in production flow and in the process itself. Analyzing real-time data can give you answers about available capacity and the actual used capacity. It shows where in the process products are potentially waiting for the next phase. It identifies rework undertaken and scrappage of product. It's not all about how busy we are, but how efficient are we producing. Can we produce more with the same capacity in machines and man-hours? Additional and sudden sales orders can be scheduled in the process without too many disruptions, and with the know-how, it can be done. Having all process information in real time available related to product in process triggers actual production stoppages and corrective actions. In combination with the procurement process and procedures in place, a more efficient inventory management can be realized, potentially reducing the inventory stock value. Industry 4 is nothing more as identifying each individual product in an early phase of your production process, scanning this item and all process points, logging this as an event in your systems, creating the controlling and monitoring tools for your production management, having real-time visibility of the actual production process, manage your inventory in stock and on the work floor, manage the production capacity, increase the production output, reducing your waste and reducing your cost. By making all information available online and real-time for all stakeholders in the process. This can be including your salespeople, this can be including your customers. A KPI score panel dashboard, as shown here as an example, can help visualizing the collated information in a single, easy-to-understand overview. The system also provides you with information to trace a product and already supplied product, reverse through the production process, to learn from failures in the process, provide liability of the process and product produced, improve the handling process in case of guarantee claims, speed up the search of related product and process information. It opens the availability to trace your products after delivery to the customer, improving your after-sales support. And we're back at the starting point. By introducing unique individual product identification in combination with allocating the used components to this product, collating all process data such as time, location, pressure, heat used, we can calculate the true costing of your operation per item produced. We can increase the quality of products produced, and we can provide information to customers during the production of their order, in the transport to delivery, and even after delivery. The technical components: RFID identification, barcode identification, sensor technology, interconnectivity, automation, learning and improving real-time data, cloud application with database management. The popular term for all this is Industry 4. However, we prefer to thinking cybernetics. I hope you all can now say, this is the end of my presentation. Thank you very much for watching. Please feel free to contact me or my colleagues if you want to have any further information. We're looking forward to hearing from you. Goodbye.